Hello, what we're going to do today is we're going to talk a little bit about relational design. What I'm going to do is I'm going to show you how to make a surface, how to import that surface as an external reference in a part file. We're going to use a piece of software called Catia V5, and we're going to talk a little bit about relational design in solid modeling. So what we'll do is we'll create a surface, and then we'll create an assembly in which we'll bring that surface in as an external reference. We'll use it to trim a solid. We'll then create another rib, and we'll morph the part, and it'll contour to the surface. We're going to be talking about relational design in Catia V5 solid modeling. What I want to do is I want to start out with a brand new environment, Catia V5 environment, and we'll make this this project from scratch, and I'll step you through it of how we'll create a surface, an assembly, a part file, and we'll copy the part file, and we'll use our surface as an external reference in relational design in Catia V5. So to begin with, we'll create a new part. Type in P for part, select the part, hit OK. We'll type in master surface. Hit OK. Now we're in a part file. Call it master surface. So what we need to do in this part file is we need to create a plane, a couple of planes to sketch on. So we'll create an offset plane from the YZ plane. We'll just pick an arbitrary distance of 1/2 inch. We'll create another plane at 10-inch offset from the YZ plane. So what we've done is plane 1 is offset 1/2 inch again, plane 2 is offset 10 inches. And we'll reframe that. So we'll begin on plane 1, we'll select it, and we'll start sketching on that plane. Hit OK. We're now in the sketch environment on plane 1, and we're going to create some geometry to help create a surface. So we'll just use the spline tool, create a fairly simple spline here. Everything I'm doing here is strictly arbitrary. This is a teaching tool for this little demonstration. We'll exit out of there. And we'll exit out of the sketch here. So what we've done here is we've created a sketch on plane 1, and we've created it in our geometric set environment. We probably really should have created that sketch in the part body, so I can copy that sketch and I can paste it into the part body. Paste it. So now it resides in the part body. Well, we need that sketch to create the surface. We can delete it out of the geometric set area. So now what we'll do is we'll create another spline on plane 2. Again, we'll select the plane, select our sketch tool, hit OK, and we're beginning to sketch on that plane. We'll just create another spline, fairly arbitrary, just a little bit below our existing spline. We're keeping the bottom points below the XY plane of the origin axis of the part file. Exit out of the sketch. So again, we've created 2 sketches, one on plane 1, one on plane 2, and we're defining contour, which in this case is a spline, to define a surface within GDNT. Not GDNT, generative shape design. So we'll toggle into the surface area, shift, so you can see the toolbar. We'll go into surfaces, we'll go into multi-section surfaces, which is basically a loft surface. We'll highlight it. This will allow us to create a surface, a loft, with the constraints of these 2 splines. Select spline, sketch 1, or sketch 2, sketch 3, hit OK. We've now created a surface. We can exit out of that. So, now what we can do, since we don't need to see those planes, we can hide show those planes. We can also hide show these sketches so it's not so busy. We can also go in here to properties and rename this multi-section surface to master surface number 1, whatever you like. Hit OK. So what we've done in this part file, we've created, as a review, we've created 2 planes, plane 1, plane 2 with these offsets. We've used those planes to create sketch 2 and sketch 3, which have got splines in them. And then we use those splines as our definition for our master surface. So our master surface definition is done. Now what we can do, we can toggle into and create a product, which is an assembly in Catia v5. The SO calls an assembly a product. So what we'll do is we'll go to type in P for product or part, select the product, hit OK, and we'll call this product a rib assembly. So what we've got is a brand new Catia v5 product or assembly, which I call assembly, which is this rib assembly. We'll populate that rib assembly with a part. For example, we'll go into Insert, New Part, and we'll call this Rib 1. This is where we're going to do the work in terms of creating a rib. So we're still in the assembly. We'll toggle into the reference part of this part file, and we'll start creating a solid in this part file. So we're going to create a plane. We're going to offset it from the YZ. We'll just take an arbitrary 1-inch distance off of that, and we'll start sketching on this plane. So we need to really go into the part body. We could go right click, define and work object, or we could just go down here and select the part body. So we'll select the plane, select the sketch, hit OK, and we're now sketching in this part file under this part body. Here's our sketch we're working in right here. So this is going to be a fairly simple sketch. I'm just going to pick the rectangle tool, make a simple little rectangle, dimension the rectangle. We'll just create something with about a 10-inch width, a 10-inch height. Dimension that feature there, half of the 10 inches up to that plane, which is 5 inches. Hit OK. Look at it normal to it. Oh, and you still need to define that as 10 inches. Now we've defined our sketch. We can blow those dimensions out a little bit, and we can exit our sketch. We've now defined sketch geometry that we can use to make a pad. We're in generative shape design. Generative shape design, you can create sketches, but you can't create solid bodies in generative shape design. So we'll toggle into generative shape design and toggle back over into part design. Now we'll create a pad. We'll toggle on the pad function. We'll select our sketch. The pad width is going to be, the total pad width will be a 1/2 inch, so I'll type in 0.25 and I'll mirror it. So on each side of the plane it'll be a 1/4 inch, total 1/2 inch. Hit OK, and we've created our first solid. In the center of that solid is plane 1, which has an offset from the origin axis of 1 inch. If we like, we can hide show this so it doesn't get busy here. So anyway, now what we're going to do, we'll go Window, Tile horizontally, and we'll import this master surface, which is this master surface right here in this part file, as an external reference in this rib 1 part. So I can right click on it, I can copy it, I can paste special as a result with link. That is, that it will maintain a link with this part file in the existing rib 1 part. So we'll go into this part file again here. Oh, I noticed I'm a little bit short on in terms of the width of this part. I want the bottom of this part to line up with plane XY, so we're okay here. And we'll take, when we do the split of the surface, we'll take this lower portion of this solid, and everything above the surface will be split off. So since I made the pad a little bit short, I can toggle into that sketch, modify that sketch on the fly, and change that to 10 inches. Change the total width to 20 inches. Exit the sketch, and the part updates. So now what I want to do, again, like I'm talking about, is I want to use my surface to split this solid and just maintain everything on the lower portion of this solid. And I've just created extra surface here, so I have plenty of surface to split this solid. So now what I want to do, I'll expand that external reference, and I'll show you kind of what's going on with that external reference through the parent-children relationship. So this master surface is a result, that is, it was a copy-paste, a keep link from this master surface.cat part. So I'll go into Insert, Surface-Based Features, Split, and the splitting element, of course, will be our master surface. If I wanted to keep everything above, I'd leave this arrow as it is. If I want to keep everything below, I'll toggle it down, and it'll keep what's underneath the surface. So I'll hit OK, and we've now created a split using an external reference master surface. So again, we can kind of go into this external reference, and we can see the parent-child relationship. We can see that we've now taken that result of master surface, which is a copy of the master surface, and we split it. We can exit out of that. So also we can add additional features to this rib 1 part file. If we'd like, we could take and create a draft. Which is a shell. We'll type in a default inside thickness of 0.1, and we'll select this face here. Hit OK. So now what we've done is we've just added features to our solid, made it a little bit lighter. So to review, what we've done is we've created a surface, we've created an assembly. Within that assembly, we've created a part file, which is a rib. We've brought in an external reference, which is this master surface, and we've used that master surface to split our solid. Now what I want to do is I want to create a copy of this rib, paste it into the assembly, break the link, and modify the offset plane from 1 to 9 inches, and morph the part over into this location here, and also maintain the top surface in the relational design with our master surface, and have 2 ribs in our rib assembly. So in order to do that, I'll toggle into the rib assembly. I'll right click on the rib, I'll copy, I'll go back into the assembly, I'll paste special, and I want to break link here so I can rename it and have a new part file. So I've just copied rib 1. I can right click on it, go to properties if I like, and go into the product. I can change the name of this copy to rib 2. I can copy that part name, which Catia v5 calls their reference, and I can paste it into the instance name. Hit OK. So what I've done again is I've created a rib 2. I just toggled into that part file. We can scroll down here and we can kind of see that we have the same type of thing going. We have a result of the master surface. I copied that external reference when I copied the rib 1. We also have the same geometric set, which is plane 1, which has an offset of 1 inch. Now what I'd like to do is I'd like to change that plane 1 definition from an offset of 1 to an offset of 9 inches, which is over in this area right in here. In order to do that, all I have to do is just double click on the offset, and I can change that from 1 inch to 9 inches. Hit enter. It automatically morphed rib 2 part, moved it into the correct location because it's based on the definition of plane 1, and it matches the contour of the surface because it's tied to this external reference, which is master surface number 1. And we also maintain the parent-child relationship of the result of master surface and the split. Toggle out of that. So now again to review, so we've created a surface, an assembly, a part, copied the part. Now we have 2 ribs in this assembly. Now what I'd like to do is I'd like to go back to this surface definition, to our master surface, modify the master surface, and see how it affects our different part files, and see if our part files will update and conform to the external reference. Before I do that, I'll open up each of the part files in its own window so we can better see and use the individual part files. So I'll just right click on here, rib object, open a new window. I'll go back and tile horizontal. I'll go back into my assembly and open up rib number 2. I'll toggle onto the assembly. Rib object number 2, open up a new window. So again, I'll just tile horizontally, so I've got 4 windows open. Here's my master surface, here's my rib assembly, here's my rib number 1 and rib number 2. So now, well, like I said, we're going to go into the master surface, double click on the bar up here, we're into the master surface, and I'm going to change this master surface, and we'll go back and we'll see how it affects the different part files in the assembly. So I'll click on sketch number 2, and we'll just arbitrarily change some of these point locations, and we're going to see how it's going to affect our part files. Everything I'm doing here is arbitrary. Those point locations I can just move by toggling and then physically moving them. Get out of the sketch, and the surface is now updated. So now what I can do is I can go back into the part files and see what's happened. Window, tile horizontal, and we see that we have the color red in the assemblies and in the individual rib 1 and rib 2s. That color red indicates that an update is needed in order for the changes to be reflected in the assembly and the part files. We'll toggle on to part rib number 1 first, and we'll do the update, and we'll see the change. We also note that in our external reference that we have a red indicator here. That indicates that we need to do an update on the part, and we can check also in the parent children relationship area, and the X is also telling that an update is needed. Toggle out of that. So we'll go into the Tools workbench and we'll hit Update All or Control U, and it will update. And it will update the rib 1 part to conform to the change of the surface of the master surface. And we can see here that we have a green icon next to this loft icon that tells us that everything is good. So we've now updated the change to rib 1. Let's go into rib 2 and we'll update the change on rib 2. Window tile horizontal. We still see that rib 2 needs an update, so we'll toggle on that. And we'll hit the update and we'll update the rib 2. We'll go window tile horizontally. So what I've kind of showed you how to do today is I've showed you how to make a master surface, how to create a rib assembly, which is a Catia product, and then we've created a part within this product called rib 1. We've copy, paste special, break link, rib 1, and made a rib 2. We've morphed the rib 2 part, moved the location from a station offset of 1 to a station offset of 9. Anyway, my name is Mike Kearsley. I work in the aerospace industry in the Puget Sound area. I work on Boeing airplanes and Airbus airplanes. I'd like to make a little advertising plug today about a great engineering graphics program at Lake Washington Technical College. They're located in the Seattle metro area on the east side, just off of Freeway 405, about 2 miles to the southeast of Totem Lake Shopping Center. Great program. You can sign up for their engineering graphics program or take individual classes depending on your background. If you're interested, look them up on the web. Lake Washington Technical College, Engineering Graphics Technology Department. You can make a phone call to Gene Foshheim, Ken Brown, Scott Acton, or Bob Mandy. Great program. Well worth your time if you're interested in solid modeling. They also teach Autodesk products. They have programs in mechanical engineering, civil engineering, and architecture. So this concludes this video on Catia V5 relational design. Any comments, criticisms? Shoot me an email. Talk to you guys later.